Large language models are absolutely everywhere, right? They're writing our code, they're summarizing docs, they're powering some incredible new apps. But there's this huge question lurking just beneath the surface. How do we actually know if what they're producing is any good? So, where do we even begin? Let's dive in.
The core problem really just boils down to trust. The University of Florida puts it pretty bluntly. They warn that these tools are prone to hallucination. That's the fancy word for just making stuff up. And that's a huge deal, right? Especially if you want to use this technology for anything remotely important.
And it's not just about those wild hallucinations. These systems can be so unpredictable. You can change one tiny little word in your prompt and get a completely different, sometimes way worse, answer. It's creating what you might call a quality crisis for developers. And for users, it creates a massive trust gap.
So that really is the million-dollar question, isn't it? How do we move out of this unpredictable Wild West and get to a place where we can measure quality in a systematic way and actually build AI applications that we can count on?
And look, the solution here isn't some magic tool you can just download. It's really about a change in mindset. To bring some order to all this chaos, what we need is a framework, a structured, systematic way to evaluate our models and build that trust from the ground up.
Some folks at Google actually came up with a really helpful framework that breaks this whole challenge down. They say a really solid evaluation strategy is built on three main pillars. First, the data sets you use to test your system. Second, the metrics you use to score it. And third, the overall methodology that pulls it all together.
Let's kick things off with datasets, because honestly, everything else depends on getting this part right. Think about it like a final exam for school. If the questions on the test are just bad, or they don't even cover what you're supposed to learn, then what does the final grade even mean? It's totally worthless. It's the exact same thing here.
So what makes for a great data set? Well, a handy model to use is the 5 Ds. First, it needs a defined scope. What exactly are you testing? Second, it's got to be demonstrative of how real people are actually going to use your app in production. It has to be diverse enough to catch all those weird edge cases. And this is a big one. It must be decontaminated. That means it can't have any data the AI was trained on. Because if it does, it's literally like giving the student the answer key before the test. And finally, it has to be dynamic. It needs to grow and change as your application does.
All right, so you've got your top-notch data. Now what? Well, you need a way to actually measure performance. So let's jump to that second pillar and look at how the way we judge AIs has changed over time.
For the longest time, the go-to standards were these metrics called Rouge and Blue. And honestly, at their core, they're pretty simple. They just count how many words or phrases in the AI's answer overlap with a perfect golden answer that you wrote beforehand. More overlap equals a higher score. Sounds pretty reasonable, right? Well, not so fast.
And this right here, this is exactly where that whole word counting thing just completely falls on its face. Just look at candidate A. It's factually completely wrong. It says Apollo 11 went to Mars. But because it shares a bunch of keywords with the correct answer, a metric like Rouge might give it a great score. Meanwhile, look at candidate B. It's a perfect summary, it's just paraphrased. Because it uses different words, it might actually score lower. It's just nuts.
So here's the bottom line. Those old metrics, they can count words, sure, but they have absolutely no clue about the meaning behind them. They can't tell a catastrophic factual error from a perfectly good paraphrase. And for the kind of LLMs we have today, that's just not good enough.
So this brings us to the new way of doing things. We call it LLM as a judge. Instead of counting keywords, we use another powerful LLM to actually evaluate the first one's answer. We can ask it really specific things like, hey, is this response factually correct? Or, how relevant is this to what the user asked? It's a total game changer because we can finally get at those more fuzzy, nuanced qualities.
Okay, that all sounds fantastic in a lab, right? But what happens when you try to use these advanced evaluation tools out in the wild, in the messy reality of building and shipping real products? Let's get a reality check from the folks on the ground.
And this isn't just theory. Don't just take my word for it. Here's a developer on Reddit talking about RAGAS, which is a super popular evaluation framework, and you can just feel the frustration in their post. The scores are so unreliable, so all over the place from one run to the next, that they just don't feel comfortable using it. It defeats the whole point.
And this person is definitely not alone. You hang out in developer forums long enough and you hear the same things again and again. Scores are inconsistent. The frameworks are a huge pain to integrate with custom setups. They don't work well on languages that aren't English. The whole thing just feels like another black box. It puts you in this really tough spot. Do you trust the unreliable automation, or do you pay for slow, super expensive, but accurate manual review?
So what's the big takeaway from all this real-world feedback? It's that LLM evaluation is very much still a work in progress. There is no silver bullet here. Not yet, anyway. It's a field that requires a really thoughtful, combined approach.
So if one tool isn't the magic answer, then what is? Well, it means we have to stop thinking about evaluation as a one-time thing. It's not a final exam you take at the end. It's a loop, a continuous process that's baked into the entire lifecycle of your AI app, from the first line of code to production.
And this loop basically has two big phases. First, you've got offline evaluation. This is all the stuff you do before you deploy, back in development. You use those pristine, golden data sets we talked about to test out new prompts or models. Then you have online evaluation. This happens live, in production, running on actual user data to see how your app is doing in the real world. So, this pre-production loop, this is how you build real confidence. You start by testing a new idea against your trusted data set. Next, you evaluate the results using an LLM as a judge to get scores on your key metrics. Based on those scores, you iterate, you tweak, and you improve. And only when you hit that quality bar you set do you promote it to production. That, right there, is what data-driven AI development actually looks like in practice.
Now, once you're live in production, that same evaluation process turns into something else, a set of real-time guardrails. Think of them like a safety net. They're constantly watching the inputs and outputs, and if they spot a problem, like a hallucination, or maybe a sign that a user is getting frustrated, they can step in immediately. They might block the bad response, retry the prompt behind the scenes, or flag it for a human to look at. It's all about catching problems before a real person ever has to see them. So we're heading towards this future where AIs are grading other AIs, all in this constant loop, with us humans kind of setting the rules and curating the tests. And that leaves us with this really fascinating final question to chew on. As we build these systems, is our own human judgment becoming less important? Or is our ability to define what good even means in the first place actually becoming more critical than it has ever been?